Today we're going to be graphing inequalities. The first thing we're going to be looking at is this line. We have 4x minus 2y is less than 8. Okay, if you see here we have an inequality sign, so we're going to get this into slope-intercept form. I'm subtracting 4x. This will cancel out. I'm left with negative 2y less than negative 4x plus 8. Remember, your goal for slope-intercept form is to get the y completely by itself. Here I'm going to have to divide by a negative 2. Okay, remember you're dividing each term by that negative 2. This then gets your y by itself. Okay, remember you need to flip the sign since we just divided by a negative. So now it's y is greater than 2x minus 4. Okay, so this is the line here that we're going to be graphing. Here's my graph. First thing I'm doing is going down 4. That's my y-intercept, putting my first point. Then I'm using my slope, which is 2 over 1. So I'm rising 2 and running 1. Okay, now before you connect the points, keep in mind we're doing inequalities. This sign here tells us that this will be a dotted line. Okay, remember to put your arrows at the ends. Okay, next part is our shading. We need to choose a test point. I'm going to choose 0, 0, and basically what I'm doing is I'm plugging in 0, 0 and seeing if indeed this is part of the function. If it's not, then it's down here. So I'm going to test 0, 0, which means I'm replacing y with 0, and then I'm replacing x with 0. Once I simplify, this will cancel out since I'm multiplying by 0, and I'm left with 0 is greater than negative 4. Now I have to ask myself, is that true or is that false? Okay, this turns out to be true. Since that is true, this point 0, 0, which I chose, will then get shaded in. Okay, if it had been false, I would have shaded away from the point and not chose to shade in that side. Okay, the next problem we're going to be looking at is going to involve absolute value. So this time we have y is greater than the absolute value of x minus 2 plus 3. Okay, so the first thing we want to do here is decide which way this absolute value function is moving. Okay, first thing I notice is that I have a slope of 1, so I'm just going to make a note of that, slope of 1. Okay, now I'm looking on the inside. Since it's minus 2, that means I'm moving 2 units to the right. Okay, now I'm moving to the end. It's plus 3, which means I'm going up 3 units. Okay, keep in mind, this here is your vertex. So now when I begin to graph my function, remember I'm going right 2 units and then up 3 for the vertex point. Okay, my slope was 1, which means I'm going up 1 to the right. And then remember we're trying to make a V, so I need to go up 1 to the left 1. Okay, again, this here is greater than, so I will have a dotted line. Okay, don't forget your arrows on the end. Okay, last thing I need to do is my shading. Okay, again, I'm going to pick 0, 0. The only time you can't pick 0, 0 is if your function is lying on the 0, 0. Since our function is away from it, we don't have to worry about that and can choose 0, 0. So I'm going to test 0, 0. I'm going to rewrite our function this way I can line it up. I'm plugging in 0 for y and then 0 for x. Now I have to clean this up a little bit. Okay, 0 minus 2 will give me the absolute value of negative 2. Remember, once you have absolute value down to one value, when it comes out, it will become positive. Okay, remember that absolute value is a distance from 0, so negative 2 is 2 units from 0. And once I simplify one last time, I end up with 0 is greater than 5. Okay, we all know that this is not a true statement, so it's false. So since we just tested this point and it's false, I don't want to shade in that region. So I'm going to shade in up here, which is away from that test point. Okay, and that's the end of our video.